In this video, we're going to look at the derivatives of the remaining trigonometric functions. We've already done sine and cosine, so now we want to look at tangent, cotangent, secant, and cosecant. Now we know sine and cosine, so we can actually use the quotient rule to find the derivatives of the four remaining trig functions. So let's just do tangent. So we know that tangent is just sine x over cosine x, right? So the derivative of a quotient is low d high minus high d low over low. Well, this is just cosine x squared plus sine x squared x over cosine squared x, which is 1 over cosine squared x, which is secant squared. Secant squared. So, not too bad. We know from our previous, because sine and cosine, we know that the derivative of sine x is cosine x, where the derivative of cosine x is negative sine x. So notice you take the cofunction and change the sign. Same thing with tangent and cotangent. We take the co-function of secant, which is cosecant squared, make it negative. Notice that the derivative of secant is secant tangent. So we're going to take, for cosecant, we're going to change secant to cosecant, change tangent to cotangent, and make it negative. So really, as long as you remember these two, we can use the rule that we just take the cofunction and make it negative. Now, let's do a few problems. Derivative of tangent. Well, we know that one, right? It's something we should memorize. Secant squared. So, how do we apply these rules? So we're going to combine a couple of rules here. This is a product, so we've got to take the derivative of x, which is just 1. Well, let's do this. Let's write y prime equals 1 and minus tan. So what's the derivative of tangent? That's secant squared, but we've got the minus, so minus secant squared. Here we've got x secant x. Now this is not a sum, this is a product. So we're going to have to do the first times the derivative of the second. Derivative of secant is secant x tangent x plus the second times the derivative of the first, which is just 1. So we get x, yeah, we can just leave it like that. You could factor a secant out, but no reason to. All right. So notice here, this summary shows that much of the work in obtaining a simplified form of a derivative occurs after we differentiate, okay? A lot of times we'll differentiate, particularly when we're using product and quotient, and we're going to have to simplify it down. Okay, note that there are two characteristics of a simplified form: the absence of a negative exponent and the combining of like terms. So if there are like terms that are going to pop up, like you can't see the like terms right here until after you've distributed, but once you do, you can see there are like terms. Same thing here. You don't see them in here, but there are like terms, right? The 2 cosine x, we can get rid of them. Here, there's a lot going on here. A lot going on here. And there's a lot going on here, you just can't see it. Okay, so make sure you go ahead, multiply everything out in the numerator or the denominator 1, either one. Make sure you combine all your like terms and get rid of any negative exponents. So if you have any questions about that, please just shoot me a reminder or ask a question in class.